We discussed about what do all the assets and bases have in common. So we are going to next activity. So this is yesterday we discussed about this all things, and this is try to understand. So yesterday we discussed about this activity. So in this activity mainly discuss about this asset to assets we took, and that is we took HCL, and then we discussed about HTSO4. Then they asked to take solution of C6 S12 O6 and C2 H5OH. Okay, so where these two will not able to glow the bulb because of what's up, not glow the bulb because of no ions. Okay, so by this activity we come to know that we concluded that yes, because of in the formula, because of in the formula there is an hydrogen, we can't categorize those things as acids. Okay, there must be a condition is whenever we're adding acid to the water, they must produce water H plus, and then we can call them as an acid. So similarly, if it is B, they has to produce water OH minus S. Now today we are going to discuss about what happens to the acids are, what happened to the acids and bases. So when they are added in the water solution, okay, water solution, so the acids produce the ions only in aqueous solution. Let us discuss. Okay, so they are asking to take uh, 1 gram of NaCl and clean dry test tube should take test. Set up the apparatus as shown in the figure 2.4. So you can see here they are given sodium chloride here. Test tube they are taking, and they are adding dropper containing H2 super concentrated H2 superlative, and then after they are closing with a rubber cork, and there is one pipe here, glass tube is there here inside, and this to the glass tube, something else gas is produced here. So just let me write reactions. Let to discuss here. They are asking. So test tube they are taking these all things. So what's are 1 gram of NaCl, and they're add some concentrated sulfuric acid to the test tubes. And what you observe is there is gas coming out of the delivery tube. So this is delivery tube. This glass pipe is called delivery tube. Test the gas evolved successively with dry and wet litmus paper. In which case does the litmus paper changes the color? So they are asking on the basis of above activity, what do you infer about the acidic character of dry HCl gas and the solution? So now we can see if the climate is very humid, and you have to pass the gas through the produced to the guard tube, drying tube and containing calcium chloride. This is also important here. So here let we can discuss about this activity first. Now see there is an activity here. Try to understand. First thing you should understand that in this one they are taking here sodium chloride. So let me write here NaCl. So right in HCl, so what they're taking here NaCl in test tube, so, and they're adding concentrated H2SO4. Concentrated H2SO4. Yes, sir. Here, it is an NaCl sodium chloride, and they're adding what's that? They're adding H2SO4. What happens sir, here? So let me discuss this reaction here. Okay, this gives rise to what kind of reaction? See once. So hydrogen will come here, and then Na will come in the place of hydrogen. Then we'll get the HCl gas. HCl gas will come plus you can say formation of Na2SO4. Okay, so Na2SO4 is not important. So as we are discussing right now, this HCl is going to produced in this reaction. Immediately when you are adding, they are dropping a containing concentrated H2SO4. They are adding concentrated H2SO4 here, and then this gas is going to produce. And that's why they are closing with this rubber cork. Okay, rubber cork here is there, and there is a glass tube here. This glass tube is called a delivery tube. Delivery tube it is called. Through this glass tube, this dry HCl gas is going to pass. Okay. So now they're asking to find out. Suppose this HCl gas is there, and they're asking to test this HCl gas. First thing what they are taking, sir, they are taking the litmus paper. Which paper, sir, they are taking? Blue litmus paper. Which color, sir? Blue litmus paper. First condition, it is a dry blue litmus. This is remember. Similarly, now same HCl gas, again same thing. Now blue, instead of dry, they are taking wet blue litmus they are taking. Wet blue litmus. In which condition? It's very well. This acid is HCl is an acid, right? So acid have a this HCl will produce HCl will change which papers are blue paper, blue litmus, blue litmus into which colors are red color. So as it is acid. You see here they are taking the dry. And this here they are taking what, sir? They are taking here dry in case you are taking it wet, or we can say moisture, moist you can say. So in which case this color is going to turn into red color. See, it suppose in the case this case, see this case, this blue paper remains blue only. This blue paper they took here, this blue will remains blue only. Which cases when it is dry cases, okay. But this here this is blue was there, no, this is blue paper was there. When they taken the which one, wet paper, so slowly this blue paper turns into which color, sir? Red color. Why this is so, sir? Why this is so? This is the question here. So now see, try to understand here. Is it really this acid is responsible for the what you call acidic character HCl? Answer is no. Okay, so I try to understand here. This acid is not responsible. Complete HCl is not responsible here. Try to understand here. Okay. Here, this HCl, when they are adding to the water, what happens? So it produces H plus ions, or we can say H3O plus ion. This H3O plus ion is called hydronium, hydronium ion. Okay, hydronium ion they will call. These ions are responsible for which characters are acidic character, acidic acidic property, completely depending upon what's our H plus ion. Okay. Now in case you see it, this if I take an HCl gas, dry gas, if I take in two cases, HCl, if it is dry, what happens, sir? So we can say no H plus ion, no H plus ions will not produce here. Okay. Similarly, if I take an HCl, we can take wet paper. When you take in wet, what happens, sir? We can say it is an aqueous solutions, means here there is an water. So when there is an water, then H plus ions or H3O plus ion plus Cl minus, and these ions are responsible for the color change of indicators. Try to understand. If it is dry gas, there is no H plus ion. That's why we can't expect a change in the litmus paper color. Now see, if I taken one more thing here in this activity, you should remember that this activity something is we have a guard tube. So what is this word work of guard tube? Okay, so they given here. You can see here they given here. So there is an guard tube. Okay, so in the guard tube, so you can see the guard tube, there is an calcium chloride. What is role of this guard tube? Guard tube will be absorb the moisture. What's that? Absorb the moisture. I remember this question they asked in 2022, 2020, I think 2022. Corona batch actually. Okay, Corona batch. They asked what is the role of this guard tube for MCQs. They given option A, option B something else. They given option C something else. And okay, so guard tube work is what, it will absorb the moisture. Even this is used in the activity which explains about explains about rusting of iron, rust of rusting of iron. Okay. Now see, so this is about this activity. So in this activity, you should remember that. So here again I am saying, so there is an test tube where they took sodium chloride and concentrated sulfuric acid, right? And after reaction, HCl gas is going to be produced. To collect that gas, they're closing the test tube with an what's a rubber cork, and they are make a hole and they kept in a glass tube. Through the glass tube, dry HCl gas is going to move outside. So in that part, they are keeping the two litmus paper. Both are blue color. One is dry litmus paper. Successively means immediate. Next one they will keep on wet litmus paper, or we can say moisture litmus. So here you see, try to understand. In first case, HCl is pure HCl is going to pass us through the litmus paper as it is dry litmus paper, so that there is no H plus ions. So H plus ions are responsible for the acidic property and responsible for the color change of indicator, so that we can't expect the blue litmus paper will not turns into red color. Okay, so now same activity, same HCl gas is going to pass us through the wet litmus paper. Wet litmus paper means, try to understand, along with litmus paper there is an H2O also, which will make that HCl to react and to form the H plus ions or the H3O plus ions, hydronium ions, and which are responsible for the acidic character, which are responsible for the color change of indicator. That's why in second cases, HCl is going to show its acidic property due to production of hydronium ion. So in this activity, there is something called GAR tube. So if it is day is humid day, where is a more amount of H2O will be there, moisture will be in the atmosphere. That is called humidity. Especially in the during the rainy season, more amount of moisture will be in the atmosphere. In that cases, see, in this activity, what we are doing actually, we need to pass the dry litmus paper, sorry, pass the dry HCl gas through the dry litmus paper, first cases. So to make sure that one, so HCl should not be mixed with a moisture. So to ensure that one, we are passing dry HCl gas through the GAR tube. So we are passing dry HCl gas through the GAR tube to make sure that it doesn't mix with the moisture, so that we can do activity perfectly. Second cases, what we anyway we are passing the HCl through the wet litmus paper. In that case, it will react with what's up H2O, it produces H3O plus ions. In that cases, we can expect the color change of litmus paper. Okay, so now see, so here they given something else. This experiment suggests that hydrogen suggests that hydrogen ions in HCl are produced in the presence of water. This is very very important point. So in the presence of water only hydronium ions are going to produce. The separation of H plus ion from the HCl molecules cannot occur in the absence of water. If there is no water, so no water, what we can say, no H3O plus ion, or we can say no H plus ion. So what we can say, no acidic, no acidic property. It means acid will not show the acidic property as this activity is concerned. Okay. Now see, hydrogen ion cannot exist alone. So here one more thing is there, but they are exist. See when we are saying hydrogen ion. So you try to understand here. So little bit we should go for the depth chemical bonding. Okay. So we know very well. So this hydrogen is it. Try to understand. So we discussed that there is an HCl will be there, and we are adding to the water. It is going to produce H plus ion. Okay. Is it really is H plus ions are exist alone independently? Answer is no. You try to understand because the hydrogen atomic number is one, so it has 1s2, 1s1 configuration. It has KCl. In KCl only one electron is there. This H will become H plus by losing one electron. You know very well hydrogen contain one electron and one proton. Now by removal of this electron, there is only one proton which is not stable. It is not stable. Okay, not stable, and no more electrons with this X plus. How this exists? It will does not exist. That's why I try to understand. With H plus there is an empty orbital will be there. Okay, one s empty orbital is there, it required two electron, and that can be fulfilled by the what's a water. You know very well water is made up of two hydrogens, and there are two lone pairs are there. This lone pair is given to the empty orbital. Okay, so that H2O plus H plus forms what's a forms H3O plus. This is called hydronium ion. How this hydronium ion is exists. That's why whenever we are writing H, we are not writing only H plus, we are writing a bracket. So bracket represent it is not stable. Or we can write H plus, we'll write immediately in the aqueous. This is exist in the water as it is gains 2 electron. You know very well what kind of chemical bond this is called. This is bond. This is called coordinate coordinate covalent bond. Which bonds are coordinate covalent bond? Because you try to understand, first these electrons are transferred to the empty orbital of 1s orbital of hydrogen. Again those electron only will share between this oxygen and this hydrogen. This is how H plus ion is exist. Try to understand. Okay, so after this one they given here, we have seen that acids gives the H3 O plus ions or H plus aqueous. Here they written here AQ. Okay, and in the water, let us see the what happens when acids and bases are dissolved in the water. So similarly, what are the bases is dissolved in the water? Similarly, how this bases will be there? Similarly, as we discussed yesterday, so when we are taking the bases NaOH in the water, what happens? It forms Na plus ion, sodium plus ion, aqueous sodium plus ion and OH minus ion. Similarly, if I taken the calcium CaOH taken twice, so this gives rise to what, sir? Ca plus 2 ions and 2 OH minus ion. Hydroxide ion they are going to produce. Similarly, you can see KOH produces K plus and OH minus. Hydroxide ions they are going to produce. Similarly, so bases generally, see one more thing that understand here, bases generate hydroxide ions in the water. Bases which are soluble in the water is called what's a alkalis. Here one more thing is there are two type of bases are there. Two type of bases are there. What are those, sir? So see, suppose we have a bases means what, sir? Which will produce a OH minus ions. Okay, bases which is soluble in water. Some kind of bases are there. They are soluble in the water. They will soluble in the water. Some are there bases which will not soluble. Will not soluble, or we can just sparingly soluble, not soluble or completely they will not soluble. Okay, so try to understand it. So these which are soluble in the water is also called, along with is also called, they are also called what's are alkalis. So what we can see, how we can define, sir? Alkalis are the bases which are soluble in the water. Alkalis are the bases which are soluble in the water. Try to understand. What are the alkalis are? These are the bases. They are soluble in the water. Those are called what's are alkalis. So remember, what do you mean by alkalis are? Alkalis are the nothing but those are the bases which is soluble in the water. What about bases? Just their bases only. So we have there is one statement. What statements are? All alkalis. All alkalis are bases, but all bases are not alkalis. What does it mean, sir? Let's understand. Whatever alkalis are there, all are soluble in the water. All alkalis are soluble in water, but all bases will not soluble in the water. Try to understand what I'm saying. See, whatever alkalis are there, what they are bases. They are all all alkalis soluble in water, soluble bases. That's why only they given the name as alkalis. Similarly, all bases are not soluble. They are not soluble. Which are soluble, for them what we given, sir? We given name as alkalis. Try to understand. This is the difference between the, sometimes this statement is given. Justify the statement. All alkalis are bases, but all the bases are not alkalis. Justify the statement. It means what, sir? You try to understand. Again, same thing only should explain. Bases are there, they are categorized into two ways. Some bases are soluble in the, especially like if I taken the KOH and NaOH, these are called strong bases. Strong bases usually are soluble in the water. Those are also called alkalis. Which are not soluble, those are called only just bases they will call. Okay. So what you should justify, sir? Here you should write all alkalis are bases, but all the bases are not alkalis. Means all the alkalis are soluble. Soluble bases. There are two category of bases. Some bases are there which will soluble in the water. Some are which will not. Which are soluble, for them we given the name as what, sir? Alkalis we given. Which are not soluble, just we are calling them as a base, not alkali. So let us here you see given the statement, all the bases do not soluble dissolve in the water. An alkali is a base that dissolve in the water. So they are so free to touch, bitter and corrosive. Never taste touch them. They may be cause which bases in table 2.1 are called alkalis. 2.1. Where is 1? 2.1. So you should see the table. 2.1. 2.1 table. So 2.1 they given, so here they are 2.1, so they given here CaOH taken twice, KOH, and these two are the potassium, sodium generally usually they are soluble in water. Even calcium hydroxide is also soluble. Magnesium is sparingly soluble, we can say. Ammonium hydroxide is also, we can say, alkali because it is soluble in the water. So we can say here, so maximum this is alkali, this is alkali, this is alkali, this is also, you know very well, lime water is colorless, it means soluble. So magnesium hydroxide is sparingly soluble. This if you have a doubt, that will discuss afterwards. Okay. Now see. Now see. So after this one, what are the given are here? Now see. So this is about alkalis and bases. Let us discuss about this. Now see, now we have identified that all the acids are generated H plus ions in the, and all the bases will generate OH minus ions. We can view the neutralization as H. What do you mean by neutralization? Right, understand. This is very very important. Many times we will not understand properly what does it mean neutralization reaction. Simple thing is here, एसिड है बेस है both react करके बाद salt और now try to understand it. Acid is due to what, sir? Due to H plus ion. कब तक H plus ion रहेगा अब तक एसिड एसिडिक प्रॉपर्टी के बताते हैं. Okay, acid it will show the acidic property. Similarly, bases until what it will produce OH minus ions, it will show the basic character. Now see what happens in neutralization reactions, sir. Why it is called neutralization reaction? Try to understand why it is called neutralization. Okay, try to understand. Let me explain here better. See, suppose I will take the bases. I will take the acid. So I will take the acid. So I will take this is HCl, right? This is an HCl, and we are taking a NaOH. So what happens are here actually? Why it is called neutralization reaction? My question is try to understand why it is called neutralization reaction. Why it is called neutral? Why it is called neutral? Okay. So try to understand here. See here. Neutral means what, sir? See here. Here there is an acidic character. Okay, acidic character, and similarly there is an basic character. Basic both will undergo cancellation. How it is possible? See, HCl plus NaOH, right? See, HCl will show the HCl is what, sir? It is acid. Why it is acid? It have a H plus ion. Similarly, NaOH is a base. Why it is base, sir? It have a OH minus ion. So now once this is base. Now once reaction is taken place, what happens, sir? This Na and Cl will combine. They'll form something called NaCl. This is none of our business. Okay, now see, H plus ions is responsible for sir acidic character. Now this H plus ion came here. Similarly, OH minus ion is responsible for what sir? Basic character. Now it combined with its H plus ion. Both are joined and they become what sir? Water. Now see in this reaction mixture, what we have? We have NaCl and what we have? We don't have H plus and OH minus, we have a H2O. So no more H plus ions, no more OH minus ions. That's why what's our acidic character is nullified by what's our OH minus ion. H plus ion have acidic character that is neutralized by the OH minus. Both will combine, they form water. This water have a what's our water is formed by what's our formed by H plus and OH minus ions, which are responsible for the acidic character and basic character. This is the complete understanding of neutralization reaction. Okay, neutralization reaction. Okay, so now see. Now we can go for the next concept what they given here. So now the, something else again about activity 2.10. So process dissolving this blah blah blah. This is something else that I understand. Process